So let's jump right into JASP by doing a t-test and crosstab on the huge General Social Survey. And we'll open up an SPSS file of the General Social Survey. Now, I've already cut out about 100 variables from this, and those were the ones where we ask what country somebody's from. So we cut it down to a reasonable size, which is still quite large. Now, you might notice that there's all these 110s here. And that is because in the merry way that this program made it from the original data file to the one that you see now, the missing values did not come across. And they show up as things like 110. So let's get a frequency count just from a couple of sample variables, and we will see what we can do about that. So while it's waiting for the descriptives engine to show up, which is a rather interesting delay that I think is unique to this version of JASP, the missing values are basically things that we arbitrarily say this is something that we don't want to deal with. Okay, so here you see how many valid answers there are, and then missing is 0. But we know that there are some people who refuse to answer questions or were not even asked the question. And those are people that we'd like to say are missing, that we don't have it. So there are 3 values for this. I believe 110 was not asked. I think 115 was not applicable. And I think 120 was refused to answer. And there's also 105, which you see is not really appropriate for work self. Do you work for yourself or someone else? These are the appropriate replies. You're self-employed or you work for someone else. And these others are all missing. And there are 105 through 120. So let's go through and we'll tell the program in the settings that 105, 110, 115, and 120 should be ignored. And then we'll set the current workspace with these values, which basically means apply, but written in the worst possible way. And now you see that we've got some missing values. And now these numbers make sense. Do you work for yourself or do you work for someone else? You have about 11.5% and about 88.5%. And then 4% of the total we say is missing. It's not applicable to us. We want to pretend that it's not there at all. That's what missing means. And it's important to realize that other, you see here there's 199 others. That's not the same as missing. That's something that we want to keep. So that is a very convenient way to get rid of those inappropriate values. So now let's go and we'll do an independent samples t-test, being very careful to stay under classical statistics and not travel into Bayesian. And we want to see if doctors visit, and what I'm doing here is I'm typing the first few letters of the variable, and that finds it in the list, because otherwise I would be here clicking through forever and you would get really annoyed with me. So this is how often you make doctor's visits, how often you see an alternative doctor, and we'll just leave it at that. We're going to do t-tests with both the student's test and the Welch test. And the reason for doing a Welch test as well is because you don't have to worry about whether the variances of the two groups are the same. So a student's t-test, there's 2 formulas. There's one that's a simple formula that you use when the two groups have the same variation, when the numbers bounce around about the same for each group. And then Welch is for when they don't. So let's see, we'll do some assumption checks to make sure that we are matching the necessary assumptions. Actually, we're going to leave out normality and just look at equality of variances so that we know which of these to use. And the grouping variable, we're going to look for whether people's parents, let's see, were born here. Parents born. And now here we see that there's 9 levels to parents born. And the most that the computer will allow us is 2. So let's take a look at parents born. And we'll have to tell it to give us frequency tables. So you normally do want frequency tables. And here we see what's going on here. Both parents born in the US, about 71% of the sample. Neither born in the US, about 20%. And then you've got all of these, and you don't really know what's going on with these guys, and there's not that many of them altogether, so we want to exclude them. So now we're going to go into the data and we're going to try to find parents born. Here we go, parents born. We double click here, and here's all the possible values that we have. Now, there's two ways to deal with this. If I was using SPSS or another program where it's easy to create a new variable and just say, okay, I'm going to compute parents born 2, where 0 continues to be 0, both born in the US, 8 continues to be 8, neither born in the US, and everything else is missing. That's what I would do in SPSS. That would be a clever way to do it. However, if you've ever tried to compute a new variable in JASP, you will know why I don't want to do that here. So we've got two choices. We can either declare 1 through 7 to be missing, or we can filter them out entirely by clicking on these check marks. And if there's an X, it means that we're taking out all the cases that have them. And this is the easier way to do it. If I wanted to set up missing values just for this variable, I could do that too, but then I'd have to laboriously go 1 plus 2 plus 3 plus, etc. So we're not going to do that. So let's go back to analyses. And now, miraculously, it should be able to do our independent samples t-test. I think it's having a hard time with alternate doctors, so we're going to take that out, and we're just going to look at doctor visits. And here you see the statistics, but that doesn't tell you everything that you want to know. We also want to know the actual averages, so we have to click here on descriptives. But now let's take a look. The assumption checks. P is much higher than 0.05, so we're going to say that the variances are the same, so we can use the student's t-test. There's also no warning sign here. Normally, let's take out the assumption check. If there was a problem here, it would give us a little asterisk and it would tell us. So we can take out the Welch's and just use student's t-test. And now let's take a look at the averages. And we see that here, where neither parent is born in the US, the average is 2.4, and where both parents are born, it's 2.8. There's about 1,200 cases here. 1,200 people answered the question, so it doesn't take much to get a significant answer. And here we see that the answer is definitely significant. Less than once in 1,000 times we would expect to see something this big due just to random chance. And you see here that it is significant. There is a difference where if both are born in the US, it's a higher mean. And just to make sure that we understand what having a higher mean for that question is, for doctor's visits, we can go through and we can look up doctor's visits here. This is normally something that you do first. I will admit I did it before we started the video. And you can see that the higher you go, the more often people are seeing the doctor. And you can also see that, of course, if you look at the actual data, that's really the best place to look at to see it. So I'm just looking for doctor's visits.
Please hang up and try again.
And here we have doctor's visits. So now when we double click on this, you can see the labels. So it's 1 is never, 2 is seldom, up to 5 is very often. So again, the higher you go in numbers, the more often people see doctors. So what we're seeing is it's not a huge difference. So you can say that it is significant, but you can ask whether it's really meaningful. And for that, you would probably want to do something where you look at a table showing you exactly what's going on. So you can say contingency tables, and you can put in parents born under columns, and then we can put in doc visit under rows. So you see that there's a chi-square is significant, and what that means is that there is some sort of a relationship between these two variables, which we knew from the t-test. So let's take a look at the column percentages. And here you see that for people, both of whose parents were born in the US, the largest group is sometimes, followed by seldom, followed by often. With the neither born in the US, 24% of people, neither of whose parents were born in the US, never see the doctor, compared to only about 15% of those whose parents were born in the US. So sometimes it's still about the same for both groups, but the never column is a lot bigger for people, neither of whose parents were born here, and the very often column and the often column are higher for those whose parents were both born in the US. So that's maybe easier to explain to people and easier to see what the difference is, because averages are great for analysis, and they are very robust, so comparing averages is really good for seeing if there is a difference, but explaining what's going on is very hard to do with averages. So if you can create a table, and they call these, normally they're called crosstabs. This is an easy way to see what's really going on here. And that's it for today.